Hello, welcome to 1.5, Solving Linear Equations. Now, a linear equation is an equation that can be written in the form mx plus b equals 0. So it may be an equation that looks different at first, but you can at least simplify the equation to look like this. Now, we have seen equations y equals mx plus b. So it's sort of like we're setting the y equal to 0, and I will talk about that shortly. For now, I'm just going to do a few examples of solving these equations. So first, let us solve the equation 24 minus 7 over 6x equals minus 7 over 6x plus 24. So the idea is to combine the like terms. So this term has an x in it. I'll try to combine it with the term on the other side with an x in it. But when that happens in this particular example, notice both of those terms cancel out, and we are left with 24 equals 24, which is true for any x. Right? So what I mean by that is no matter what I plug in for x, these two terms will still cancel out and would be left with 24 equals 24, and that's obviously true. So we make the conclusion that the solution is all real numbers. Now, if the terms with x canceled out and we were left with something false, like 3 equals 2, then we would conclude that there is no solution, but we were left with a true statement once the x terms canceled out, so that's why there is infinitely many solutions. Okay, so kind of a weird example. Let's look at a more interesting example now where there is a unique solution. Say we solve the linear equation 8x minus 4 equals 7x plus 1. Well, again, combine like terms. So we're left with 1x minus 4 equals 1. Add the 4 to the other side, and we solved for the x. X is 5. Okay. Another example. 7x minus 2 plus 6x equals 2x plus 4 minus 4x. So we will combine the like terms, have these terms with x that are like terms. So on the left hand side we have 13x, right hand side we have negative 2x. Okay, now we can combine these like terms. 15x, I'll add the 2x to the other side, equals 6, 15x equals 6, x is 6 over 15. Okay, so hopefully we are understanding this. We just combine the like terms and then get the x by itself. Let's look at an example like this. 9 times the quantity x plus 1 equals 7 minus 2 times the quantity of, let's do 9x plus 8. Okay, so what we have to do here is distribute the numbers into the parentheses, and let's be careful about that minus sign. Okay, so on the left hand side we have 9x plus 9. Right hand side we have 7 minus, well, negative 2 times 9, it's negative 18. Negative 18. Then we have negative 2 times 8, that's negative 16. Okay. And now it's just like last problem where we combine the like terms and then solve for x. So I could add the 18x to both sides 27x plus 9 equals 7 minus 16. 27x equals 7 minus 16, and I can minus the 9 to the right-hand side. So 27x equals negative 18. Dividing the 27 over, we have x equals negative 18 over 27. We could simplify that if we want to 2/3. Okay? So, again, all we do is combine like terms, solve for x. So that's the idea of solving linear equations. Let's now look at some applications of linear equations. So I already wrote this problem down to save some time. We have a truck that enters the highway at 60 miles per hour. A car enters the same highway 13 minutes later at 73 miles per hour. They're driving in the same direction. And we want to solve how long it will take for the car to pass the truck. So I'll draw a picture here. Let's say this is time 0 when the car enters the highway. So I'll draw a bird's eye view of the road. Let's say this is the truck driving at 60 miles per hour. And then down here is the car driving at 73 miles per hour. Okay, now the truck has been driving for 13 minutes already. So it's going to have a head start. So the first thing we could do is figure out how big that head start is. What is the distance between the truck and the car at this time? And I'm just saying that's time 0, just when the car enters the road is when we're going to start the stopwatch and start timing how long it takes to pass the truck. Okay, so we know how fast the truck is going, and we know for how long in this particular snapshot, right? The inconvenient thing is we're given minutes here, but then we're given miles per hour. So what I'm going to have to do here is convert hours to minutes. And, well, we all agree that there's 60 minutes in an hour, right? So if we cancel these hours out, 60 miles per hour is equivalent to 1 mile per minute. It's equal to 1 mile per minute. And that makes sense. If you're driving a mile per minute, in 1 hour you will go 60 miles. Okay? So, therefore, this is 13 miles. And you can see that because of the following. Well, we know that speed is distance over time, right? So if we play around with that equation, we have distance is equal to speed times the time, right? So the distance, if you do 1 mile per minute for 13 minutes, right, that's 13 miles. That's why we know, since the car is driving a mile per minute for 13 minutes, that the truck has a 13-mile head start on the car. Okay, so now let's turn our attention to the car. The car is going 63 miles per hour. Excuse me, the car is going 73 miles per hour, but we could convert that into minutes, because in 1 hour there's 60 minutes. So really the car is going 73 divided by 60 miles per minute. Okay. Let's see, can I'll just leave it like that. Okay, let me draw another picture now. Let's say time has progressed. This is sometime in the future now, when the car passes the truck. So we'll have the truck here. The car finally caught up to the truck, right? So the truck has still been moving. The truck did not stop and let the car catch up to it. So the truck has gotten an additional amount. I'll call that X. Right, so when the car first entered, the truck had a 13-mile head start. That's when the car first entered the road. But a little bit into the future, an unknown amount into the future, the car will eventually catch up to the truck. But the truck was not stopped, it was moving, so the truck is still moving an additional X amount of distance. Okay? Now, let me rewrite this formula we had. Speed is distance over time. Okay, we'll use that. Okay, so how can we solve this? Well, we need to solve for time. Right? So looking at this equation, time times speed is distance. Time is equal to distance divided by the speed. Okay, well, we know the speed of the car. I'll say SC. That's 73 over 60 miles per minute. Okay. So if time is equal to distance time divided by speed, we could plug in this speed, and we need to plug in this distance, 13 plus x, and solve for time. Alright, so plugging in, we have time is equal to the distance. Right, clearly this is the distance that has been driven. In this snapshot, we have 13 plus x. And the speed, let's consider the speed of the car. It's 73.60. Okay, so one thing you may be noticing is, well, we have two unknowns here, and that's not good. We want to just solve for time. So let's try to think about this x a little more. X is the amount the truck has driven since the car entered the road, and while the truck was driving, the speed of the truck was driving at 1 mile per minute, right? Okay, so we could use the formula that the speed of the truck is equal to the distance the truck has driven, which in this case is x, divided by time it has been driving. Okay, I'm just plugging into this formula. Since the last snapshot, the truck has driven x distance divided by some time. We don't know the time yet, that's what we want to solve for. We do know speed. We can plug in speed to this formula as well. The speed of the truck is 1 mile per minute. Okay, now I can multiply t to both sides of this equation. T equals x. Well, that's good. If t is equal to x, I can just replace this x with a t, because x equals t. Okay, now we just have one variable, and now we can solve for t. Okay, so we need to combine the like terms. First, let me get rid of the fraction here. I'm going to multiply this to the other side of the equation. So we'll have 73 over 60t equals 13 plus t. Okay. to solve for t, so could minus t to both sides. And then we have 73 over 60 t minus 1t equals 13. Okay. Well, 73 over 60 minus 1t is the same as 60 over 60t. Hopefully you'll agree that 1 is the same as 60 over 60. Okay. So we have 73 minus 60, that's 13 over 60. T equals 13. Okay, almost there. Now I can divide both sides by 13. Cancel these 13s out. These 13s will cancel out. And then I have 1 over 60 t equals 1. Multiply both sides by 60. Those cancel and we have t equals 60. Remember, we were in terms of minutes, so in 60 minutes, the car will pass the truck. We have solved the problem. Okay, kind of a difficult problem, but hopefully you followed along. Let's look at another problem here. Let's say we pay, let's do 8%. Let me reword this so I don't have to write as much. Let me say how much interest is gained if we take a $2,100 loan for a year with the yearly interest rate of 8%. So if we earn 8% interest in a year, how much interest is that? Well, thing to notice is 8% can be written as a decimal as 0.08. Then all you have to do is do 2,100 times 0.08, 168. So I left out a few words in my writing. It wasn't very clear, but what I mean is, in a year, if we have a 8% interest is taken out in that year, how much interest have we gained in that year, and then you just do 8% times 2,100. So pretty easy. Let's look at another problem. Say we work 48 hours in a week and make $1,350. Okay, after 40 hours of working, we earn 2.5 times our usual rate, usual pay rate. What is our rate? Okay, well, how can we solve that? Well, let's put this sentence into an equation. We were working 40 hours applied to our unknown rate. I'll call the unknown rate x. And then we worked 8 hours applied to a 2.5 times our rate x. And that paid off 1350. Okay, so we have 40x plus 20x, right? 8 times 2.5 is 20. Okay, so 60x equals 1350. Divide the 60 over. X is 1350 over 60, which is $22.50 is the rate at which we are paid. Okay, the last thing I wanted to talk about is how to find zeros of a function. And it's really just the same thing I was doing at the beginning of this lesson. It's just a new way of asking the question, but how to solve the question is the exact same thing I did at the beginning of this lesson. So let's consider this example. Find the zeros of the function f of x equals 3 over 4x minus 6. Sorry, 3 over 4x minus 6. So what finding the zeros of the function means is we set f equal to 0 and solve for x. So when you see finding zeros of a function, that means you set the function to 0 and then solve for x. So if we do that, we have 0 equals 3 over 4x minus 6. And now solving this problem is just like what we were doing at the beginning. We could add 6 to both sides, and we have 6 equals 3 over 4x. I could multiply 4 to both sides. Okay, so these 4's cancel out. So we have 24 equals 3x. I could divide the 3 over. X is 24 divided by 3. So x is 8. Okay. And that is about all we will see in this section. Thank you all for watching.